Hi guys. So our next assignment, this one is going to be due on March 31st. Okay. So I have 3 examples to do with you, and then I gave you quite a few, I think 6 or so, to do on this assignment because you guys were amazing at this. It doesn't take too long. Okay, so we'll jump right into it. We are talking about simplifying radicals today. Radicals is the little square root sign. Okay, so let's get right into it and get going. Okay, simplifying radicals. Let's zoom in, and most likely you guys will need a calculator on this one. Okay, so we'll zoom in to the square root of 256. Okay, so when we're trying to find the square root of something, what it actually means is we want a pair of 2 of the exact same numbers to be able to come out of the radical. Okay, I tell you guys if they can pair up, they can leave the house, go on a date, right? Okay, so we are going to find the square root of 256. Hint, if you don't know that this is a perfect square right off the top of your head, you could solve it anyway. Okay, so we can see that 256 is at least an even number, right? It ends with a 6, it's an even number. So in your calculator, you could do 256 divided by 2. Okay, 2 times 128. We're always dividing on these. Always dividing. Okay, or in other words, 256 divided by 2 will give you 128. Okay, you can keep going. 128 divided by 2, 64. Okay, and this might be where you're like, oh, 64, I know that that's a perfect square. I know that 8 times 8 is a perfect square. Okay, so now that we've divided it down to where we can see numbers that are pairing up, they can start to leave the radical. Okay, so I can see that I have a pair of 8s. One pair or one couple of 8s can leave my radical. Okay, but I can also see that another pair of 2s can leave the radical. Okay, when they become on the outside, they're now multiplying. Nothing was left inside my radical, so I really just have 8 times 2, which is 16. That does work. Sorry, I'll box it. That does work because the square root of 256 is 16. Perfect. Okay, so that one was a perfect square, but we can see what we're actually trying to do. We're trying to get pairs of numbers that leave the radical. Okay, so let's do number 2 now. Number 2 we can see actually has a variable. This is the square root of 80 times m. Okay, we know that 80 is not a perfect square number. 81 is, but not 80. So we're going to have to divide it down to try and find pairs that can leave. Okay, but again, I know that 80 is an even number, so I can divide it by 2. I get 40. Okay, I don't have a pair yet, so I can keep dividing. 2 times 20. I do have a pair right there of 2's that can leave my radical. But let's see if anything else can. 20 I can divide 2 times 10 again. 10 can be divided 2 and 5. Oh, there is another pair. So 2 times 2 out front. Okay, this 5, we now can see that every number has been divided down. 40, 20, 10, they've all been divided down to this 5. So the only number left inside is a 5. Okay? Awesome. But now we need to look at the variable. Variables are treated the exact same way as numbers. Okay, we just have one m here. Just one. Okay, that m cannot pair up with another m. Therefore, it has to stay inside my radical. It cannot pair up and go on a date. Okay, so the only thing I need to do now is just simplify 2 times 2 in front. 2 times 2 will give me a 4 root 5m. And that is simplified. Okay, the square root of 80m is 4 root 5m. Okay, awesome. Let's go to number 3. Kind of a big number. We have more than one variable. We have an m and an n squared here. But let's start it the exact same way. On my calculator, just to check, I'm going to see if the square root of 384 is a perfect square. 384. Nope, it gives me a decimal. Definitely not a perfect square. So we're going to need to break it down. Okay, 384 is a big number, but that's okay. We can keep breaking it down by 2's, right? 384, we know it's an even number. So 384 divided by 2, 192. 192 is also an even number, so we can divide it by 2. Divide by 2, 96. Okay, I have a pair of 2's that can leave so far. So that one can leave the radical. Let's see if anything else can and if anything stays inside. 96 is also an even number. Let's see, divided by 2, 48. Okay, this is where you might get numbers where you're like, oh, I know 48 can be divided by 8, right? 8 and 6. Okay, so now I have 2, an 8, and a 6. Sorry, I kind of ran out of room here. But there's no pairs that can come out yet. So let's keep, in fact, I'll do this over here. So we have 2 times 48, just so we have more room, 2 times 48, 8 and 6. Okay, so let's keep simplifying. 8 can be divided by 2, 2 times 4, 6 can be divided 2 times 3. Okay, I see a pair of 2's right there. So now I have a 4, a 2, and a 3. Let's see if I can find any more pairs. A 2 and a 2. There's one more pair of 2's. So 2 more 2's got to come out aside my radical. And what I have left is this 2 and this 3. Okay, they cannot be simplified. They're both prime, and they cannot be paired up to leave. Okay, so what they turn back into is this 6. Okay, so a 6 actually stays inside my radical. So that was a lot of breaking down for a big number. That's okay. Okay, so now let's talk about our variables. Okay, so we have 1m right there. So we know that that 1m cannot pair up and leave. It has to stay inside. But now n squared we can rewrite as n times n. Okay, those n's actually can pair up. They can pair up, and one couple of n's can leave my radical. One couple of n's. One couple can go on a date. Okay, one couple can go on a date. One pair can leave. Okay, so now I'll just simplify. 2 times 2, 4 times 2, 8. 1n got to leave. 6m had to stay inside. Okay, so a lot of simplifying. That's okay, you guys were great at this. Okay, so you have 7 problems to do on your own to submit either through Canvas or on Woot Math, your choice. You just have to do one of those. But make sure that gets submitted to me by March 31st. Okay?